All right, Alberto, on Monday, Gizmodo came out with an article about how to clean your disgusting earbuds. So it's a funny article. It's serious, but it's not really about wireless charging directly, but there's a really important wireless charging element of where the earbud industry is going. And I want to read a couple quotes, and then I'm going to get some reaction from you. So looking at the Gizmodo article, first of all, it starts with a quote that says, "Your wireless earbuds probably spend a lot of time stuffed inside your ears, and no offense, but your ears aren't always the nicest place to be. You can practice good hygiene, keep your earbuds lasting longer, and avoid grossing out anyone else who might catch sight of them by making sure you clean them regularly." Okay, that's a nice setup. So yes, we know that oleic acid, your earwax, is very corrosive. It's it's not the most beautiful human chemical byproduct. So there's a need to clean them. But then it goes on to examine the Pixel Buds, the Google earbuds, and then Apple's AirPods, and talks about how to clean them. And I did a word count here, and in a 500-word article, it used the word dried or dry 12 times. And these are earbuds that are supposed to be used in sweaty environments, potentially in swimming pools, potentially in the rain. So what is the big deal? Why do these earbuds need to be dried off? What is it about cleaning these earbuds that you can't run them on? Apple says, avoid running them underwater. Ensure no moisture stays around. Make sure your AirPods are completely dry. So what's the obsession with keeping these devices dry?
Well, yeah, and it's quite a need and it's quite a problem. The main challenges are that it cannot be a completely sealed product, right? Mm-hmm. Because it inherently it's an earbud, so it needs to have it needs to have a speaker or some sort of way to produce sound, and some also have a microphone and also a way to charge it.
Now, my understanding is that speaker and microphones are pretty water resilient now, and there's pretty established gasketing and other waterproofing technologies for those. So do you think most of the water ingress into the devices comes through the speakers and microphones, or is it through the charging pins, or is it a combination?
I think there's definitely a combination. From the connector side, the main problem is corrosion.
Okay.
Corrosion can just make the connection unreliable. But yeah, that's one of the main benefits that wireless power can bring. If we can remove that connector, then it's one less avenue for the earbuds to fail.
Yeah. So what you're talking about is on each of these buds, there's either 2 or 3 pads, or on the Apple AirPod, there's a little ring of metal on the bottom of each tip that's slit in half.
Yes.
And what those do is they make contact with pogo pins inside of the case. So if you look into the case, you can see gold dots.
Right.
And those are used, what are those used for?
Those are used mainly for power. And on some applications, they're also used for data to transmit maybe some firmware updates or some other type of communication. But power is a common denominator on all these earbuds.
Right. So it makes sense, like just intuitively, to get rid of that, right? Yeah. Like we get rid of plugs, we waterproof devices. We like to get rid of complexity, and we like to seal them up. And after all, these go in your ear. They go in the swimming pool. You wear them when you work out. So it just makes so much sense from a user experience perspective to get rid of them. However, you just brought up something really important. We can do wireless power, and we should talk about how you do wireless power in these really small devices. But data is sometimes overlooked. Yes. So talk about like what happens in the factory and why these contact pins are not going away as quickly as maybe it would seem like they should, just from an intuitive perspective. Like, why do the companies keep putting pins and pads on their devices, even though wireless technology is available?
One of the main reasons is that it's not as easy to bring wireless charging into these devices.
Okay. Why is it hard? What's hard about putting wireless charging in these
devices? You kind of have in the industry kind of two or three really possibilities for wireless power. You got the Qi or low frequency systems. Those require typically either a thick leads wire that needs
Yeah.
some big area, and those are usually unviable to fit it into.
Simply put, Qi is just way too big for earbuds.
Yes, pretty much.
Okay.
Then you have the higher frequency ones.
Okay.
And then there's some inherent challenges on higher frequency ones. You still have the low coupling of these devices. You get the benefit of a higher frequency, but the antenna sizes are relatively small still, even for higher frequency. So coupling efficiency and heat are some of the main challenges there.
Right.
You also have some complications like mass adoption. You got the Airfield standard, but it hasn't been kind of widely adopted.
Right.
So you're gonna get into the fear of, you adopt this type of wireless power, but then it's, in a couple of years may become obsolete if something comes along that is not widely adopted. That's where NFC comes in. That is kind of like widely adopted technology that has the benefits of higher frequency, but then it also brings in some complications of how do you send power while also guaranteeing that communication, because NFC wasn't really designed for that for that type of wireless power. It was designed
That
for
much
data.
wireless power.
Yeah, for that much wireless power. So that's another complication, guaranteeing power and data. And then there's also the EMI and compliance challenges of high frequency devices, since we are an intentional radiator.
Yeah.
It's just in general for high frequency devices, it's just more challenging to have a compliance system.
Yeah, so each one of these we should break down separately.
Yeah.
But basically, the reason why you don't see wireless charging right now in earbuds, even though it makes intuitive sense and would clearly benefit the end user, are because of size,
Yep.
power levels,
Yep.
and then how that corresponds to thermal and how much heat it creates.
Exactly.
EMI, and integration challenges of, that are related to all of this, but the trade-offs between form factors, antenna positioning, location, the orientation of how you can put them down. So yes, this is a very challenging environment. What I was pointing at before, because I know we're doing this right now for a customer, it's not in the market yet, so we're not going to talk about the customer, but we can talk about the technology. Removing pins for wireless power was a big part of the equation, but then they said, how are we going to program these in the factory if there's a dead battery? Because usually you just touch it with two probes and you can program it whether the device is working or not. So how do we deal with dead battery programming or debugging in the factory if you remove the debug ports?
Data, including data power on the same channel.
Okay, so that doesn't sound, data and power on the same channel sounds like basic, but why is it not as basic as it sounds?
Well, it's not as basic as it sounds, because usually what we have are kind of independent channels. You have Bluetooth that is kind of like the go-to technology for data for these type of devices.
And it requires a working radio and an active battery. You can't do Bluetooth on a dead device.
Right.
Okay.
And then you have power that usually is done either wired or through, in the Qi industry is through that wireless charging.
Yep.
But you typically mix those together.
Right.
Why? Because they're kind of like it's kind of conflicting battles. The more efficient you want a system to be, the more degradation you're going to have in data.
Data rate and power efficiency are inversely related. Is that correct?
Yeah, exactly.
Okay. And it's related to quality factors. So for power systems, you want really high quality factors. And then for data systems, you actually want low quality factors for more bandwidth.
Yeah, and then the higher the quality factor, the more overshoots you're going to have when you're doing modulation on a pin.
Yep.
And then those type of disturbance in the communication are going to make it harder for the demodulator circuit to try to understand what it's saying. So the more efficient and then the more power you're trying to transfer, the harder it's going to be to have a stable communication, and vice versa. The more stable a communication channel, the more you're dampening the field, and the lower quality factor you need on the system, and the less efficient it'll be.
Gotcha. So in addition to all of the wireless power challenges we mentioned before, you have to look at factory programming, like when you have to put in a localized language, into a product before you send it to Mexico. Let's say it's going to be
Right.
different than if you send it to Canada. So that's something you have to be able to do over the air if you get rid of the ports.
Yeah.
And also you need to be able to do it from a debug perspective. If the battery's not working, if the radios aren't waking up, what's wrong with this device? Well, if you don't have ports there, you have to be able to activate that from the outside.